In this video, we're going to introduce ellipses, which in our last group of videos, we talked about a circle, which is where you take a plane and slice a cone so that the plane is parallel to the base of the cone. With ellipses, what we want to do is we want to slice the cone at an angle, and what will happen is it creates this oval-like shape as a result. So that oval-like shape is called an ellipse. So we're going to look at, in this video, we're going to look at a lot of the pieces and parts and vocab of an ellipse, and then in the next one we'll take a look at identifying the center, vertices, and foci. So the mathematical definition of an ellipse is it's the set of all points such that the sum of their distances from two fixed points called foci is constant. And an ellipse is either going to appear to be typically wide or tall based on their equation. So below are the key parts of each type of ellipse. We have the center of an ellipse, much like we have the center of a circle. And with a circle, the radius is the same in all directions. Well, with an ellipse, it's not the same in all directions. We have the longer radius here, which is called the semi-major axis from a center to a vertex. And if we look at the distance from one vertex to another, it's called the major axis. Perpendicular to that is called the minor axis. So the major axis, if it's a wide ellipse, the major axis is going to run left and right, and the minor axis is going to run up and down. And if it's a tall ellipse, it's going to be the opposite. The major will be up and down, the minor will be left and right. And inside the ellipse, we have what are known as focal points or foci. So the distance on the ellipse, if we take this point on the ellipse and calculate the distance to this focus point, calculate the distance to this focus point, whatever that sum is, it'll be the same for every point on the ellipse. Another way to look at it is if you were to take a piece of string and pin it down at each of these endpoints for the focus points. So you have a thumbtack here, and a piece of string connecting the two focus points. If you take a pencil and try to stretch it and draw a circle, what you'll end up drawing is this ellipse. And again, the major axis, if it's a tall ellipse, the major axis is going to run up and down. The minor axis is going to run left and right. So the minor axis is always perpendicular to the major axis. So the center of an ellipse is denoted H and K, just like with circles, so that's a plus. And each focal point, on the plural of that is foci, is going to be C units away from the center. And the foci are always on the major axis. So if your ellipse is wide, your foci are going to be to the left and right of the center. If your ellipse is tall, your foci are going to be above and below. Each vertex, which the plural vertices, also lies on the major axis and is A units away from the center. So each vertex is on the edge of the ellipse. Each covertex, and the plural of that is covertices, lies on the minor axis, which is perpendicular again to the major axis. And the covertices are each B units away from the center. So putting that in terms of the vocab we had before, our center's H and K, our distance from our center to a vertex is A, and we're going to use a lot of graphing, so you don't necessarily have to memorize all these pluses and minuses here. Visualization and graphing is going to be your best friend in this section, and the next as well. The focal points are C units away from the center. So again, we're going to plot these and count left and right, count up and down, things like that. And then each of your covertices are B units away from the center. So much like a circle, everything starts from the center. And hyperbola is going to be the same thing. Again, here we have a tall ellipse where now you're going up or down A units on your major axis. You're going up or down C units for your focal points, and you're going left and right B units for your covertices. And note, in both cases, this length of C, if we square it, it's equal to A squared minus B squared, and A will always be bigger than B. So Going back to our wide ellipse, our equation is x minus h in parentheses squared over a squared plus y minus k in parentheses squared over b squared equals 1. This is our standard form when our ellipse is wide. And the value of a will always be bigger than the value of b. Likewise, if our ellipse is tall, our equation in standard form is y minus k in parentheses squared over a squared plus x minus h in parentheses squared over b squared equals 1. So the relationship between c squared and a squared and b squared is c squared is a squared minus b squared, and a is always larger than b no matter what. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.